Math 2414, differential equations, video 9. Direction fields, slope fields, part 2. This is technically part 3, but the previous video, which I decided to film on a whim, was just me showing you how in Microsoft Excel I generated all these values. But as I was writing them down, it dawned on me that these are linear in both directions, x's and y's. All that basically means is that they're skipping by the same amount, either going across or going down. Some of them were really easy to figure out. When y equals 0, this whole thing is always 0. So 0 is all the way across. You'll notice there's a 0 column here when x is -1, but that makes sense. Because if x is -1, this becomes negative y plus negative y is 0. Some other easy columns that were easy to populate were, for example, when y equals, let's go down here to y equals, let's do x, I don't know, x equals 1. Let's take x equals 1. When x was equal to 1, then this becomes y plus y, which is 2y. So for this column, you just had to double the y's. It got a little bit uglier when we had the decimals, but, you know, big deal. It's just decimals. So anyway, now we have these 169 slopes. And by the way, you may have noticed if you were paying very close attention in the previous video, or 2 videos ago, that I skipped 1 when I was labeling my y values. I went from 1.5 to 0.5. I caught that when I was copying over the slopes from Microsoft Excel onto the board, and I ran out of room down here. So I had to kind of clean it up and add another row down there. No harm, no foul. All right, so before we sketch all these, let's just talk real quick about what it means for these to be certain slopes. You should know that a slope of 0 is perfectly straight across. So this is a slope of equal to 0. And you should know that a vertical line has an undefined slope. Some people say its slope is infinity, but the truth is, it depends on whether you rotate this way or that way, whether the slope is considered infinity or negative infinity. So it's more like a limit. A perfect diagonal is a slope of 1. Where is a slope of 2? Well, that's easy if you think about rise over run. If a slope is 2, then it's 2 over 1, which means you rise 2 and run 1. So if I just quickly go over 1 and up 2 and put a dot, that would be a slope of 2. And if I went up 3, that would be a slope of 3. And same thing if I go down. If I wanted a slope of -1, it would be a perfect diagonal going down. If I wanted a slope of -2, I would think of it as -2 over 1, rise over run. You quote-unquote rise -2, which is going down 2. So run 1, go down 2, draw a line, and there's a slope of -2. So as I sketch these, I'm going to be keeping in mind what some basic slopes look like. When push comes to shove, I'll make a ratio in rise and run to find a couple of dots to connect. Let's start with the easy ones. Every time the y-coordinate is 0, my slope is 0. So all the way across the x-axis, you'll notice these axes are marked in quarters, but my values only went in increments of a half. So across each of these, I'm just going to draw a line segment, not a continuous line, because there's no guarantee that these are connected. But at each point, there's a slope of 0. And that's not the only place I can draw points with a slope of 0. I can also draw a slope of 0 every time x is -1. So if I go over to x equals -1 and locate all of my coordinates, remember I'm going by halves here. If I locate every point, yep, there's those. And this is much easier on graph paper, by the way, where the line's already drawn for you. But if I locate every point whose x-coordinate is -1 and then stop at all the increments of 1/2 in the y direction, all of these have a slope of 0. So I can draw a little line segment through all of those with a slope of 0. But let's pick one more x or y value to sketch all the slopes, and then I'll stop the video, draw the rest of them, and do part 3. Let's just pick the top row, where y is equal to 3, which is going to correspond to all the points across here. That's why it's the top row over there. So give me 1 second to put a bunch of dots up here. -3, -2.5, -2, -1.5. We already got -1. 1/2, x equals 0, x equals 1/2, x equals 1, x equals 1.5, x equals 2, x equals 2.5, x equals 3. So let's see how we can draw these slopes, starting with this first one of -6. If I wanted to draw a slope of -6 here, I would need to think of a rise of -6 and a run of 1. So I'm going to start at this point and just go a little dot to the right and then 6 dots down. 1, 2, 3, 4, 5, 6. And then kind of connect those. It's a longer line segment than I would normally draw, but that's okay. For this one, a slope of -4.5, I would probably want to think of that, well, let's just think of it as -4.5 over 1, which means at this point, at -2.5, 3, which is right here, I would go over, and I'm going to blow up what I'm doing up there because it's hard to see because I'm drawing so small. But what I'm doing to sketch these is I'm going over some small amount, but then I'm going vertically this amount using the same measurement. So if I went over this, I'm going to go down 4.5. So 1, 2, 3, 4, and then half of that. And then that gives me a line of slope -4.5. But when I do it up here, it's really hard to see because I'm putting very small dots. 1 over, 1, 2, 3, 4, and then a half down is about there. So not quite as steep as the previous one, which is expected because it's a lesser slope. For a slope of -3, I'm going to start here at this point at -2, 3 because that's my ordered pair. I'm right here. And I'm going to run 1 and rise -3. So 1 to the right and then 3 down. Puts a dot about here. And that gives me a line that looks about like that. Until the slopes start getting around 2 or 1 or 0 or -1 or -2, they all pretty much look the same. But when I go to -1.5, I'm going to think about that one a little bit differently. I'm going to think about it as -3/2. So I'm going to run 2 and rise -3 from here. So run 2 and rise -3. When I connect those and stretch it out the opposite direction, you can tell that it's not quite as steep as the previous one. And now we're already at the one that's equal to 0, and then we just do the same. So for the next one, we're at 3, we're at this point. So I'm going to run 1, and we're at 1.5. So I'm going to think of that as 1.5 or 3/2. So from this point, I'm going to run 2 and rise 3. Draw a line segment, go backwards the other way. And then at the next one, let's see, I should probably circle, well, it's going to be a mess. But my next one is here, over 0, up 3, so I'm on the y-axis. And when I'm over 0, up 3, my slope is 3. So from here, I'm going to run 1 and rise 3. Put a dot, sketch it going up, mimic it going backwards. And do the same thing all the way across. For 4/5, I'm going to do a run of 1 and a rise of 4.5. Run of 1, rise of 1, 2, 3, 4, and then about a half. So it looks about like that. You can tell this isn't exact. That's why we have technology to actually do it. Next one is a slope of 6. So over 1, up 6, 1, 2, 3, 4, 5, 6. So pretty steep. And then 7.5. So over 1, up 7.5, 1, 2, 3, 4, 5, 6, 7.5, about like that. These are getting really steep. Slope of 9, over 1, up 9, 1, 2, 3, 4, 5, 6, 7. Now, and it'd be a good idea to use a straight edge or a ruler to sketch these, because if I did take a straight edge, here's a big straight edge, and connect the beginning and the end, I really don't have to go all the way to the end because now I know where my slope is. It's about like that. 10.5. Over 1, up 1, 2, 3, 4, 5, 6, 7, 9, 10, and about a half. And by the way, if you're using graph paper, you've already got it lined out. Just remember, you don't have to connect all the way to the last dot. You just have to put a straight edge on them. Make sure you go through the middle point because that's really where the slope is. Excuse me. And then finally 12, over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. about like that. Draw a segment to the point. And there's these slopes at the points all the way up there. At this point, I'm going to pause the video, or stop the video, I should say, and I'm going to draw the remaining 156 slopes. Well, minus the ones I've already drawn. So you can see this is a time-consuming task, so hooray technology.